This video is about choosing trajectory for visiting other planets in the solar system in an efficient way to save as much rocket fuel as possible. Welcome to Virtual Pathfinder channel. I make videos about imaging and especially astrophotography. If you're interested in exploring the universe with your camera, remember to subscribe to this channel. I use affordable equipment which can reach distant galaxies as well as detailed structures on the moon. We need to talk about Mars. It may feel a bit premature since the Artemis 3 project seemed to be delayed. It's now planned for mid-2027. There are rumors that there are further delays to be expected since some problems with the heat shield for the Orion. Also, there are some delays for the Starship. And furthermore, there is also rumor that there may not be a crewed visit to the lunar surface, and it may instead be a crewed visit to the Lunar Gateway, which is a planned space station which will be assembled in orbit around the moon. So in other words, Artemis 3 may not include some of the things we were expecting, and the Artemis program may be slightly delayed in general, and that means that the permanent lunar base will be delayed, and in turn that will delay the Mars mission as well, since the lunar program is a stepping stone for the crewed mission to Mars. I estimate there is a 50% probability a crewed mission to Mars will occur during my lifetime. Going to Mars is exponentially more difficult than a lunar mission due to the long distance to the planet. If we're lucky, AI will speed up the development and enable more automation. But the time to perform the test flights is long due to the distance, so it will take a long time whichever way you do it. Let's have a look at the options when it comes to choosing trajectory for a crewed mission to Mars. Perhaps the most well-known trajectory for going to Mars, or actually for changing orbit around an object, is the Hohmann transfer orbit, which is not only used for going to other planets, but it can also be used for going from a lower orbit to a higher orbit. For instance, when you move a low Earth orbit satellite to a geostationary position, you may want to do it in a very energy efficient way, and the Hohmann transfer is the most energy efficient way to go from a lower orbit to a higher orbit. And in case of going to Mars, that is a very similar situation, since Earth is closer to the Sun and Mars is further away from the Sun. So from the Sun's perspective, we are in a lower orbit compared to Mars. And to go with the Hohmann transfer, we need to move in a tangential direction compared to the orbit. So we start out tangentially from Earth at the closest point of the ellipse, and it will reach Mars tangentially at the point that is farthest away from Earth. As I mentioned, that is the most energy efficient way to go to Mars, but it takes quite a long time. It's about 7 months. There is a good reason why we want to save energy and have as low delta V as possible to go to Mars, and that is because fuel is very heavy, and if you look at the payload of a rocket, 90 to 99% of the weight of a rocket is fuel. So you want to avoid all kinds of maneuvers that consume lots of energy. So there's a point to do all this. But there's another problem with this Hohmann transfer, and that is the return trip, which has to be planned so that Earth and Mars are aligned in a way so that you tangentially can move from Mars and tangentially approach Earth. And that creates a bit of a problem, since we need to wait for quite a long time on the surface of Mars before we can go back to Earth, and that may be up to 1.5 years. And then the round trip back and forth to Mars takes about 14 months. So the whole trip may take up to 3 years, and that's quite a long time to spend out in space, and that creates all kinds of risks for human health. The points in time where you can go back to Earth is called the transfer window, and that occurs about every 26 months. So it's a long time to wait for it. But there are some other options when it comes to choosing trajectory for going back to Earth, and some of them are very interesting. I will go into that in another video, so I will finish for this time. I hope you liked this content, and if you did, then remember to subscribe to this channel. I will make more videos about space exploration. So I'll see you in the next video then.